Let's dive right into this explainer and completely shatter a pretty common myth. It's really tempting to think that once the giant dinosaurs were wiped out, life on Earth just sort of relaxed, right? Like humans eventually inherited this tranquil, peaceful paradise. But actually, scratch that. The reality is that the planet we call home became an absolutely brutal 66 million year battlefield. We're talking about an environment that didn't just test life, it completely rewrote the basic rules of survival. Everything changed in a literal instant. Picture this. A city-sized asteroid, roughly 10 to 15 kilometers across, slams into the Yucatan Peninsula, and it is moving at a mind-bending 64,000 kilometers per hour. There were zero climate warnings, no biological alarms, just a single cold rock hurtling through the darkness of the solar system at nearly 20 times the speed of a rifle bullet. To really wrap our heads around the sheer scale of that impact, think about this. The energy release was equivalent to 10 billion Hiroshima atomic bombs, exploding all at exactly the same time. The Earth's crust was instantly compressed, melted, and almost entirely vaporized. It's an event so violently extreme, it practically defies human comprehension, leaving a crater 180 kilometers wide and drawing a permanent, hard line between two entirely different biological worlds. And this kicked off an apocalyptic domino effect that unfolded in mere hours and days, not years. Within minutes of that colossal crater forming, shock waves triggered magnitude 10 earthquakes across the entire globe. Just hours later, tsunamis over 100 meters high are sweeping the planet, while falling, red-hot debris ignites global wildfires that burn down forests that have been standing for tens of millions of years. And then, within days, an astonishing 15 trillion tons of vaporized rock, dust, and sulfur are blasted straight into the stratosphere, totally blocking out the sun. All that vaporized, sulfur-rich rock basically gift-wrapped the planet in a dense, dark veil. This created an impact winter that instantly brought photosynthesis to a grinding halt. Average global temperatures plummeted by a staggering 20 to 25 degrees Celsius incredibly fast. Earth was plunged into a dark, frozen, and chillingly silent era that lasted for 10 to 15 long years. Think about it, the familiar sounds of buzzing insects and bird calls just completely vanished across huge regions of the globe. The result of all this was absolutely brutal. Roughly 75% of all species vanished entirely. It's the ultimate proof that evolution doesn't always favor the strong, right? It favors those who can endure. When the plants died off, the herbivores starved. Then the carnivores quickly followed in this terrifying domino effect. Acid rain turned the oceans toxic, which wiped out the foundation of the marine food web. Basically, if you relied on a stable environment, you were instantly pushed into an evolutionary dead end. Survival of the smallest, the Dark Age. Overnight, the whole script flipped. Everything that made a dinosaur powerful suddenly became a deadly burden. Being massive and having high energy demands were absolute death sentences in a world with no sunlight and no food. The ones who survived? They were tiny. They required very little energy, had short life cycles, and could either burrow underground or just scavenge on whatever scraps were left behind. These survivors found themselves facing something we call biological disorientation. It's a completely shattered food chain where your natural instincts don't guarantee survival anymore. Imagine millions of years of perfectly tuned evolutionary habits being rendered totally useless in the blink of an eye. The very traits that made you a king in the Mesozoic era were now the exact things killing you. So the big takeaway here is that Earth was handed over to the flexible. It went to the small mammals that could hide away in burrows and slow their biological rhythms to survive the freezing cold. It went to the agile birds that could literally just fly away from local destruction. It went to slow metabolism reptiles like turtles and crocodiles that could just fast for months in murky, stagnant water. And it went to the hardy ferns that created this massive fern spike, thriving in the post-apocalyptic ashes and basically prepping the soil for the distant future.
The rule of giants, size as a weapon.
Now, life obviously didn't stay tiny forever. With the dinosaurs permanently out of the picture, resources eventually became lush and abundant again. And wouldn't you know it, the evolutionary pressure completely flipped once more. Surviving now meant becoming as massive as biologically possible. During the hothouse conditions of the Paleocene and later the freezing ice ages of the Pleistocene, having a massive body meant power. It meant retaining heat in the cold, storing huge amounts of energy, and using your sheer bulk as a living shield against brand new predators. Just wrap your mind around the stats of these absolute monsters. You had the Titanoboa, a massive 15-meter snake weighing over 1,300 kilograms, just baking in tropical rivers that were 6 to 8 degrees hotter than today. Then there's Megatherium, a sloth the size of an actual elephant, weighing 4 tons and using its immense muscle mass as armor. The Glyptodon was essentially a mammalian tank lugging around a 1,000-kilogram rock-hard shell. And in the oceans, Megalodon ruled supreme. A 20-meter shark with a terrifying bite force of 182,000 newtons, literally crushing the skulls of whales. For a while there, size was unquestioned dominance. A planet in chaos, the relentless laboratory. But if there's one thing we know for sure, it's that Earth simply refuses to stay stable. Tectonic plates crash together, mountains like the Himalayas thrust into the sky, and the climate violently swung back and forth. About 56 million years ago, global temperatures spiked dramatically in just a few thousand years. Then, during the Neogene period, the Himalayas shot up, which altered planetary wind currents and triggered massive monsoon systems. By 2.6 million years ago, the planet gets locked into the brutal, repeating glacial cycles of the Pleistocene Ice Age. The biosphere literally had no time to catch its breath. In this absolute chaos, terrifying new predators constantly kept the food web in a total state of terror. We're talking about things like the 1.8-meter-tall short-faced bear. There was no stable top of the food chain anymore. You had giant predatory birds, saber-toothed cats, massive prehistoric hyenas. It was just a revolving door of violence. Any period of calm was incredibly brief before the balance was shattered all over again by some new biological nightmare. Which brings us to the ultimate evolutionary curveball. Seriously, what happens when a smaller, physically weaker species suddenly shows up in a world entirely ruled by armored, 4-ton giants and towering super predators? Rise of the flexible, the human experiment. We naturally like to think of human evolution as this triumphant victory march, but in reality, we were just another desperate experiment on a highly hostile planet. Early hominins, like Australopithecus, were painfully fragile. More often than not, they wound up as a quick snack for a saber-toothed cat or a giant eagle, rather than acting as apex predators. We were a complete biological mismatch. Under 1.5 meters tall, barely 45 kilograms, no claws, no fangs, no speed, no armor. For millions of years, early primates just survived by scavenging, gathering, and trying really, really hard to stay hidden from the true rulers of the landscape. But the real game changer wasn't muscle. It was gray matter. About 2.5 million years ago, when Homo habilis arrived, brain volume expanded significantly to 700 cubic centimeters. And this is the crucial leap. It finally allowed our ancestors to plan ahead, memorize the landscape, and most importantly, innovate when physical strength completely failed them. Our survival basically came down to a very specific sequence. First, grasping hands set the foundation, letting us use our thumbs to hold objects. Then, as our brains grew, we started chipping crude stone tools. We didn't do this to dominate, we just did it to compensate for being so physically weak. And finally, the ultimate hack, the mastery of fire. Fire drove away those giant predators at night and let us artificially break down hard-to-digest roots and meats, turning them into easy energy for our rapidly growing brains. Now, it is so crucial to remember that we didn't do this alone. Evolution was basically throwing everything at the wall to see what would stick in this chaotic environment. The human family tree is full of variations that were tested and failed. We had cousins who were vastly stronger and better adapted to the freezing cold, like the Neanderthals. We had relatives who optimized for small size on islands, like the tiny hobbit humans, Homo floresiensis. Almost all of them faded away. So why did our specific branch, modern humans, actually make it? 2 words: social flexibility. Our unmatched ability to cooperate, communicate, and organize into tribes. Because back then, living alone meant dying fast. We absolutely are not the strongest, the largest, or the fastest. But with the development of early language, survival knowledge could actually outlive a single person. We could coordinate our defense, share scarce resources, and adapt to wild climate swings as a single unit. Our ultimate weapon against the chaos was, well, each other. I'll leave you with this to chew on. When we look back at Earth after the dinosaurs, we do not see a paradise waiting for us. We see a 66 million year battlefield. We emerged from the ashes of an asteroid and ran a gauntlet of ice, fire, and giants. We aren't the absolute winners. We are simply the relentless survivors in a brutal, ever-changing laboratory. Which leaves us with one final, fascinating question. What rules will Earth write for us next?